Hello, my name is Jesus Garcia. I am core system engineer for RSA, and today we are going to see a demo about how using the Netwitness platform we will be able to do the threat detection, the automated response, and also the hunting of the advanced threats. So in order to explain everything correctly, I have planned the next agenda. First of all, we are going to do some assumptions, and then we are going to do the attack explanation itself of the advanced threat. We will continue with the attack execution in real time, and finally we will be doing the analysis and investigation using Netwitness platform, and also we will be switching between the like a bonus between the source code of the artifacts that we use it for this demo. This demo will be different. We are going to run advanced threat attack in real time, and also we are going to do the analysis of all the steps and all the phases of the attack using our platform Netwitness. So let's start. This is some assumptions that we have to know before to attend this demo. The audience already knows what is Netwitness in the different vectors. The audience should know what is Netwitness logs, what is Netwitness endpoint, what is Netwitness network, and also the audience have to know the concept basic about the cyber threats and cyber security difference, like what is the difference between the EPP, the EDR, the behavior indicators, and IOCs, etc. So these are some assumptions before to start this demo. And that's it. Let's start with the explanation of the advanced threat that we are going to see on this presentation, this demo. As you know, there are different kinds of attacks that are part of the advanced threats. In this demo, we are going to focus in the advanced threat attacks campaigns. When we talk about the campaigns, that means we have 2 or 3 or more artifacts that are part of the attack. In this example, in this demo, we are going to have 2 different artifacts. The first is the seed. The seed is the artifact that normally have an extension that image or .c, .encrypted, and is not suspicious file. This file is not suspicious, and itself is not offensive. If you put the seed in the EPP is not going to be able to detect this kind of file. This file normally is the one that have the payload, the malicious payload. And this is the file that is going to be distributed across all the network. As you can see here in the image, we have the seed in the different user machines. The group of attacks normally pays for the insider, and this insider is going to be responsible to distribute it across all the network this seed. Normally it's a sysadmin, DBadmin, or one person that disabled has access to the different architecture or elements in the network. So as you can see here in the image, this seed has been put in the user machines and in the servers. This seed normally used to live there something like 2 months, also 3 months, and is not going to be able for the EPP to detect, because as I said before, this seed is not malicious by itself. And then when the group of attack or the attacker knows that this seed has been distributed across all the network and has enough servers or machines like a victim, they are going to send the trigger. The trigger normally is an artifact that has its extension .exe, .bat, .doc.pdf, and it's very attractive. It's a file that is attractive for the victim, and this trigger is the same by itself. Is not malicious. This trigger is going to search for the seed that has been distributed before, and then the trigger is going to do the transformation or the method in order to release the real malicious payload. And then the infection will be released, and the decryption methods will be started, and that's it. The infection has been is going to be released. So as you can see here, the trigger is going to looking for the seed, and then the infection is going to start. This is the demo that we are going to see on this presentation, in this demo. Here we have the roadmap of the attack in the real life. In the real life, normally the malware or the artifact is received like a spam. Normally, is the trigger artifact. For that reason, is orchestrated campaigns, and then the trigger is going to download it or to search the malicious file. I mean the seed. Then the malicious code is going to encrypt all the files to do the malicious action, to release the infection. Normally, is target, it has a very specific target when you find this kind of attacks in your network. Then the callbacks are done, lateral moves are intended, and then the endpoint is compromised totally, in a message is showed with the payment, requiring the payment. This is the roadmap of the attack that we are going to see on this demo. So let's go to the demo execution. Here I have the virtual machine that we are going to use. As you can see here, we can see the IP is the 1.1.1.5.6. This is the IP. And this machine has also installed the agent already. I have put a Netwitness agent Jesus in order to identify better. I'm going to go to our platform, to Netwitness. And here we are going to see that everything is clean, completely clean. Here we can see the EDR interfaces, and here in the dashboard we can see the Jesus PC is the same IP, has the same IP, is completely clean. We don't have any alerts, and I'm going to go to the response part. We don't have alerts, we don't have incidents. Everything is completely clean. So we are ready to start with the demo, with the execution. We have the victim machine. Also, we have the Netwitness ready. And I have here both artifacts. I'm going to copy here in Windows. And here we have the seed. This is, as I said before, this is not offensive. And I'm going to show you. I'm going to prove that. I'm going to put here this file in VirusTotal in order to analyze this file. And we are going to see that this file is completely clean. So this file that is called about encrypted normally is put it in different paths, in a hide path, in a system path or something like that. I'm going to put here in the desktop just for educational purpose and to do everything more clear. I'm going to put here. Now it's uploading. Let's wait in order that the file finish. Now it's doing the detection, doing the analysis. And here we are going to see that it's not detected. As you can see here, any engine of regular EPPs is able to detect this file because this file itself is not malicious. So this file is going to be distributed across all the network, and it's not going to be detected by your EPP. So this file is able to live in your system. It doesn't matter the time because it's not going to be detected. So imagine that you have this file in your environment, and then when the D-Day arrives, they are going to send the trigger. In this case, the trigger is this game, this Tetris game. This Tetris game is going to looking for this file and is going to release the infection. In order to show you, I have here some files that you can see here. And these files are normal, are image files. You can see it's possible to see it. And also here in my documents, I have more files. You can see here. So I'm going to open the Tetris and nothing happened. If you see, nothing is happening. Why? Because the new methods of detection of the sandboxing of these advanced tricks, they are ready for the sandboxing. So this is one perfect example. As you can see, this is the action that the sandbox could execute. The sandbox is not able to play. So the infection is going to be released until the line 3 has been completed. And I'm going to show you that directly in the source code. Here I have the source code of the Tetris. I have done this, I have developed this using C#.NET. And here we have, when the counting is 3, I have a counting of ransomware, and when it's equal to 3, the execute ransomware would be released. I have put here this message. So when the line 3 is reached, the infection is going to be released. There are not enough time to explain what exactly does these methods. I'm going just to show you. Oh, I don't know why. Let's just a second. It's here. So this is the methods execute ransomware. This I have two different key because I have do this the cipher of the malicious payload using AES algorithm, but well, it doesn't matter. The important thing here is that we are going to wait until line 3, and that is perfect because the sandbox is not going to be able to do that. So this artifact is going to wait for the interaction for the user in order to release the malicious payload. So I'm going to play and I'm going to complete the 2 lines, and then something is going to happen. Imagine that right now the victim is playing and they said, oh, it's very funny to do that. However, he doesn't know that something is going to happen when the line number 3 is reached. As we can see, we have the line number 3. Something is happening in the back. The Tetris continue. However, we can see here something happened with the files, and then suddenly the screen is completely blocked. So here we can see the normal part of the ransomware. What happened to my computer? A message is showed. This is something that is going to ask for the payment. Here we have our wallet. Also, we have a unique user ID. This user ID is going to send like a callback, like a lateral move. Here I have put some URLs. Also, we have the contact of the creators of this ransomware. Normally this kind of artifacts makes persistence and blocks all the desktop. I have put here this button exit in order to analyze the status of the machine. I'm going to click here in exit. As you can see here, the trigger continues executing. I'm going to close it. And here we can see all the files that we showed first now are completely ciphered. We cannot open it because right now they are ciphered. I'm going to try to open the documents. Also, the result is the same. The extension is .hes. It's completely ciphered. The machine has been infected successfully. Also, the wallpaper changed. Also, persistent has been done, and the victim doesn't know what happened. So let's go to our NetWitness platform in order to know what happened. That is very important. So as we can see here, we have the incidents. The incidents has been created automatically. This is the automated response that we took in the first when I present the title of the demo. I'm going to go here to the alerts. Here we have the different alerts that were triggered by the infection, and these alerts has been correlated in different incidents that has been doing automatically. One incident has been opened. I'm going to open this, the incident number 84. And here we are going to be able to see all the alerts, all the alerts that happen and are completely correlated. Also, we can see the event list. So here we can see exactly what happened in the system. However, in the first look, maybe something is very difficult to understand. But we are going to do the analysis, and we are going to see that it's not difficult to know what happened. Here we have the type of the log. I'm going to go exactly to the host files. First of all, we need to know what happened in the host. So I'm going to open the dashboard of the NetWitness endpoint. And here we know that we have the RSA score has been assigned automatically. I'm going to open the Jesus PC. And here we have that something called ransomware about suspicious activity. It was detected, and this alert has 7 events, as we can see here. Also, at the same time, some program also disabled the firewall. And finally, we have also for suspicious activity about the ransomware. We can see here, and we were able to open the alert and to try to know what is happening. However, I want to know first of all what happened, what was the action that disabled the firewall. So I'm going to click here. I'm going to know the details of this alert, and I'm going to go directly to analyze process. Analyze process is going to do the correlationship of all the alerts, and he's going to put it in the line of the time. And here we have it. Here we have all the fathers of the process in sequential mode. We have the explorer.exe, and the explorer.exe has a child that is Tetris. I'm going to click here in Tetris, and here in Tetris, we will be able to see what is happening exactly. So here we have it, that something happened, Tetris start to looking for the about decrypted file, and right now, one analyst is able to detect what is the trigger. This Tetris, here we have the action, is write and executable. That is not normal, because any program and any program that is not an installer is not able and is not allowed to write to execute to executable. And exactly that was the action that Tetris.exe executed, and rename the about decrypted, and then about decrypted rename to new executable that is called about.exe. If we come back to our endpoint that is infected, here we have it. The infection itself, the name is about.exe, and here exactly is the detection that NetWitness did. Here we have different actions that continues executing. Right now, Here is the remote tree, the open the process, uses the WMI process in order to do that. And then this Tetris file execute the abbott.exe. Right now we know the abbott.exe is the ransomware itself. And here we are able to see exactly what steps execute abbott.exe. The father is Tetris.exe, write is executable, and here we have also even the arguments of abbott.exe, and here we have different important things. Here we have also we have a callback that it was done ipinfo.io. I'm going to go to the source code of the abbott.exe in order to show you that that is for real. In fact, just a second, but we are going to looking for this callback. Let's just a second. Let's looking for exactly for the string. And here we have it. As you can see here, the artifact itself is going to looking for this, is going to do a request of this IP in order to get the public IP. And also, Netwitness was able to detect this callback. Also, another callback it was done is what it was done for the 128 IP. Here also we can see in the source code that this is exactly the callback. As you can see here, this is our callback URL, HTTP, and this is the IP. It's going to looking for kill switch, and exactly this IP is detected. So Netwitness endpoint, it was able to detect what was the trigger. In this case, it was Tetris.exe. What was the seed? The seed it was about encrypted. It was renamed and to abbott.exe, and abbott.exe is the ransomware per se. And this abbott.exe executed different callbacks and also do the ciphering. Here we can see it was renamed, so renamed to executable, and it was renamed to .exe. And that is the process of the cipher itself. And yes, here we can continue doing the analysis. And finally, also here we have the instruction about how the ransomware, in order to do the persistence, first of all, disable the firewall. Here we have the command that it was detected. In this command, normally in the roadmap of the ransomware, of the malicious artifacts, normally they are going to disable the mechanism of security. And I'm going to show you also here in the source code the part when we are doing exactly the disable. So I'm going to go here, in here. It's here. Here you can see disable firewall is going to call the run script. This run script is going to execute a PowerShell instruction, and this PowerShell instruction is going to execute the disable of the firewall. And this command, it was detected exactly by Netwitness. So right now, as you can see, Netwitness has been detected each step that the ransomware executed. Finally, also it was created the persistence. So in some, here we have a register event, and we know that some persistence was created. However, he doesn't he don't want here in this part we don't have the details about what was the register of that was created. However, it doesn't matter. We can get it. We can get it everything because all the information is here. So I'm going to go here to first incident. I'm going to navigate in the investigation, and I'm going to looking for the register that was created by the artifact. And this is a good opportunity to show you how this investigation is going to be done using all the information in the engine of the correlation of NetWitness. So here, I'm going to deactivate the profile. We have different profiles in order to do the investigation. And I'm going to select just the about.exe because right now we know about.exe is exactly the artifact that I want to know, and I want to investigate what was the register that was created. So here we have the behavior on compromise that it was triggered by this alert, this ransomware suspicious. This is the indicator of compromise that it was also triggered ransomware about suspicious. Here we have the different action events that happen. As you can see here also we have the parameters that it was triggered with this. I'm going to continue down. Here we have, this is the relays of IP. I'm going to continue finding keys or user keys. It's looking for exactly, just a second. Just a second, we are looking for the register that it was created. Let's remove this. Here we have the register that it was created. So I'm going to open this in new tab. And here we have exactly the register that was created by about.exe, created register value, and this is the value that was created. Also, we can see here, we can looking for, here we have the function that is going to create it. So for Microsoft Windows current version run, and it's called about.exe. And as you can see here in NetWitness, we have exactly the same information. We know exactly also the persistence that was created by the artifact. And also, we can go here directly to the endpoint and validate that this persistence was created successfully. So I'm going to go here. Let's go to the current users. This is the user, software, Microsoft, Microsoft Windows current version, finally run. Here we have it. The persistence was created successfully. We have seen this directly in the endpoint, also directly in the source code of the artifact, and finally, NetWitness also it was able to detect this persistence exactly. But as you remember, we know that some callbacks was done. All the investigation that we have done so far has been executed and has been done using the endpoint NetWitness. But also, if I want to know, if I would want to know what is that, what was sent in this IP, because I want to know what is the kill switch. I want to know what is my key of this attack. If I want to continue doing the investigation, also I am able to do that. How? Well, I'm going to looking for everything here in the investigate. I'm going here to investigate, and I'm going to looking for all the information of this IP, because I know this IP is the receiver. So I'm going to do the query. As you can see, it's very easy to do that. I'm going to looking for IP DST because this is the meta value that I want. I'm going to apply. And of this way, I'm going to have everything about this communication, all the communication that has been established to this IP. I'm going to select RSA web analysis, like a file. And here we have it. We have just one value of this. I'm going to open it in new tab. And also in the presentation, all the time we talk about that we are able to do the session reconstruction. Today we are going to see that. I'm going to click here and open reconstruction. And here in the reconstruction, we know it. We know that the info has been received, is processing, and this was this is the response creation success true. And this is the page that is what's reached, killswitch.php, as we saw in the analysis of the source code. However, we want to know exactly what was sent. This is something that is very important. So we can continue here doing the analysis of this IP. If I select exactly this IP, I am able to see what is the post, what is the put. I'm going to show what is the put. That is what's done. This is the methods. And right now we know, here we have it. Here we have exactly what was done. It was sent the unique key of the virtual machine, of the machine. This is the identifier of the machine. This is the domain, the user, and the IP of the machine. And this is the encrypted key. If I would want to do the decryption, I need this information, the encrypted key. How we know that this is for true? This is the detection that Netwitness did. How we know that this key is for true? Well, I'm going to log in directly to the machine that has been received this callback. Is the 128, as you can see here. Exactly is the same IP. It's exactly the same IP, 128. The file is called killswitch.php. And here we have the attack technique ID, exfiltration over command and control, initial access, infiltration, etc. Here we have the context of this kind of request. However, I'm going to show you exactly what happened. I'm going to log in to MySQL in order to show you the database of this attack. And we will see. Now we are inside. Just a second, because I don't remember what is the name of the database. It's about choose about. And I don't remember what is the name of the table. Just these victims. Okay. Let's see if that is true. Let's see if this encrypted key, if this is exactly the same. That is what sent it. So I'm going to looking for everything in victims. Oh. Sorry. Now it's okay. And here we have it. The callback, it was successful, and this is the information that it was sent, and it was inserted directly in the database of the attacker. This is the machine of the attacker, and let's looking for the information, and here we have exactly the unique key. This is the unique key, and it's WVI, exactly the same. What we have here, we have exactly the callback. We have detected what was the unique key and what is the encrypted key. If I have would uh, if I would have the necessity to recover of any way this information, I need this encrypted key. And using Netwitness, I was able to get it. So using Netwitness, we have the ability to do the detection in real time of the threat. One threat that the trigger is at 0 day. Also, that we have the alerts, we have the incident on automation response. Also, the endpoint, using the net point, we were able to detect each step that the endpoint that the attack executed. And finally, using Netwitness network, we were able to detect any callback and all the information that it was sent by the malicious artifact. So right now, we have the ability to now, if this attack, it was for real, if this attack, it was for real, we have the possibility to do the hunting, because right now we know the trigger is a tetris.exe file, and also we know the seed is encrypted, is about .encrypted file. So this is our zero patient. So we can now, using Netwitness, we are able to do the detection, to do the response, and to avoid that this infection start to move in lateral move. We can do the isolation of these of the machines that has the seed or that has the trigger. You know, so right now we are able to do that hunting. How we can do that hunting? We don't have enough time. However, we can go here to files and to start to looking for the different files in all the different endpoints that has installed our agent. So we are enabled. We are enabled to do the hunting, really to do the hunting, because we know exactly each step that this infection executed. So let's come back to our presentation. These are the conclusions that we were able to see during this demo. It was shown how it really works in the advanced tricks when there is a specific and well-specific target. It was shown how using Netwitness we can detect attacks across all the network and directly into the endpoint. And finally, it was possible to validate that using Netwitness, there is a complete visibility of all the roadmap of the attack, because we detected every part of the attack across all the roadmap of the same attack. I mean, we detect completely the methodology, and we did the contrast, analyzing exactly all the part of the source code of these attacks. These features will enable to our customer to be resilient and autonomous in the response of the security breach. So that is everything of my part. Thank you so much, and goodbye.